Okay, so we've worked our way down the pipeline. We've gone through the view volume. We've gone through clip space culling. We've gone through bounding boxes. Finally, we're down to rasterization. We're going to rasterize the points we got. So we're done. Everything that's been called has been called. So we now have to think about what happens with clipping. Clipping during rasterization. Okay. Luckily, this is an easy one. Oops, wrong one. This is an easy one. But here's the idea. Geometry on the edge of the display, it can be partially visible and partially off screen. Geometry on the edge of a display can be partially visible. And I'm going to draw a picture of this. Okay, so here's an example of what it looks like. Here's my display, and I have some triangles I'm going to draw. They might look like this. They might look like that. They might look like, right? You can imagine all kinds of variants of this. So what do we do? How do we handle this? Okay. So first of all, in general, it actually can be quite difficult. And the reason it can be quite difficult is because of complex geometry. Okay? So if we have complex polygons, what you end up doing is you end up cut the geometry. You clip it basically to match the viewport. Let me give you an example of one of the more complicated cases. You can imagine here's your viewport, and I'm going to draw some convoluted polygon, right? Right? You can have a polygon like this. And this is really gets complicated because when you start doing your point and polygon tests, I could imagine this might come down like that. How far do you go? Is it on screen? Is it off screen? Is it inside or outside the polygon? You can do it, but it's not trivial. Right? Because after you do the cut, what's inside? What's outside? So there's actually a lot of work on this. You can look up Polygon algorithms, and some of the ones we've covered briefly. But Polygon test algorithms can be used to restructure or reconstruct basically the clipped polygon. But it's a lot of work. It's confusing. There's a lot of special cases, and I don't like it. And if there's something you learn from me in this course is that let's just forget it. It's simpler to use triangles. Let's just use triangles. If you find yourself needing to do polygon type stuff, turn them into triangles. If that's not feasible, you maybe get a good graphics book or a good graphics math book and learn about how to really work properly with these polygons. So if we have triangles, it's easy. It's very easy, in fact, and it's fast. That's what we do. So remember how to do scanline fill. So when we're doing scanline fill, remember you make a bounding box around the triangle and then you scanline across it? We just clamp the bounding box to the raster. To the viewport size, I should say. So if this is my viewport, And I have some funny triangles here. I should probably use a different color. I have some funny triangles here. Right? They go off screen. You can do what you want with them. I don't know. Then usually what you do is you construct the bounding box around the triangle, and you do your scan line. But what you do is when you use minning and max, you use your the smaller point at the 0, because this would be the 0, 0 of your viewport, depending on your system, I guess. But anyways, to the 0 and to the max. So in this case, x did it again. In this case, x max, you clamp your bounding box. This case, y max, you clamp your bounding box, x min. And so you just do that. You just make your bounding boxes smaller. When you calculate min and max, you add the raster edges in as the ultimate maximums. That's it. You make smaller bounding boxes, and you do your scan line fills like usual. You can see here that you can even see if you can make it smaller. But then you have to find this intersection. So you know what? It just might not be worth it. Once we have our bounding box, we use the point in triangle test as usual. Okay. Really simple. So clipping on the screen, really simple. We don't have to deal with those fragments, no Z test, nothing like that. Bam. Now there's one piece of the puzzle that is missing. What do we do for the near and far clipping planes? What do we do for those guys? So far, let's just spell it out. This is my right. This is my top. This is my bottom. This is my left plane. I've already projected, so I'm in NDC or past NDC into viewport, so there's no depth, no breadth you want to think of it. We're already projected, we're already on the viewport coordinate system, so that's easy. But we still can't forget that there is a third dimension going this way. And so if I draw up at top down, you remember that we have this, right? This is my far, this is my near. After projection, they flatten out. Far, near. We still have to make sure we're not drawing past that or before that. Now, we could just cut anything. We could just cut anything earlier in the pipeline that's beyond those planes. And if a whole triangle is beyond the far or near, then we cut it earlier with our clip space culling. No problem. But the problem is when part of a triangle, so if I have a triangle like this and it comes out like that, right? Or a triangle or a shape, it comes out like this. The back has to be cut. The front has to be cut, okay? So you have to cut the part that comes past that cutting plane. So what we do, it's actually not hard. You still do your triangle rasterization like normal, except you modify the Z test. You use the Z test on each fragment as usual. And you just don't draw if it's out of bounds. If it's less than -1 or it's bigger than 1. So if it's outside those standardized coordinates, just don't draw it. So I'm going to give a demo of that actually. So you can see what I mean by how you can see part of a triangle that's clipped at the near plane or the far plane. It can be very confusing. Here we go, sketch 3. So here's the example. So just a normal program. We have backface culling enabled, counterclockwise, blah, blah, blah. Now what I've done is I made the frustum. Near is at 2 and far is at 6. So it's very narrow. This is so I can move those planes. And then I've made hotkeys to move the planes and to output the plane's location at the bottom. Let's see if I can make that font bigger for everybody. The console font, just make it 18. Okay. Bam. Hope that worked. All right. So then we're going to see a rotating cube, and then I'm going to move the near plane, and you'll see what happens as the near plane goes into the cube. First of all, remember when I do move the near plane, the whole projection of field of view changes, so the size of the cube will change as well. Don't be surprised by that. So as this cube, it's rotating. I'm going to move the near plane closer. It was 2, now it's 2.3. Because it's closer, you get the field of view goes in, narrows, so I'm zoomed in. Okay, oh, did you see that? Look closely. That's Google. No thanks, Google. There we go. So you see that? We're already clipping a little bit. See, it opens up. And that's when the cube is going into the cutting plane. You imagine a laser that's, cutting that off for us. Okay, I'm going to move the near plane even closer. There we go. This is what you expect to see. Bam. So what you're doing is, as it hits the near plane, it's just lasering it off, and we're seeing inside the cube. Now, because I have backface culling enabled, you can see that we just see straight through the cube. We see straight through, we just see the wireframe. If I had backface culling not enabled, we'd see the inside of the cube. So let's move the near plane off. Let's see what happens when I move the far plane. It's 6, 5.7, 5.3, 5.0, 4.7. Nope, we're still safe. 4.1. Oh, there's some clipping. You see that? Watch the edges as it goes around. They kind of like something weird happening there. And that's because they're coming out of that far plane. Let's bring it even closer. There we go. So it's kind of weird, but what's happening is the cube it's being cut off there. And it's being cut off at the per fragment level, not on the triangle or the quad level. Okay? Look at that. And now we can just bring it right in. So the cube's barely peeking out of that far plane. Now you could imagine if it looked like water, if the background was water, you could imagine how it looked like the cube is, rotating in and out of the water. And now why don't I just do both when I'm at it? Here we go. Near plane clipping and far plane clipping. So this can actually be quite the hassle for you to make sure your geometry isn't hitting these. Wrong way. It can be quite a hassle to make sure your geometry isn't hitting those, but I wanted to show you what near and far plane clipping look like, and we've talked about how it's actually implemented. And so you can see again, what they're doing is they're excluding fragments as they're doing a scanline fill once the Z gets out of bounds. Cool. All right, so my iPad went to sleep. That's it for our clipping thing. Clipping lecture.